Any conversation about the sustainment of military aircraft invariably touches on the issue of managing obsolescence. Here, upgrades and modernisation are crucial, ensuring that long-serving aircraft can continue to play a vital role. Indeed, upgrades can help solve a range of issues, resolving obsolescence and improving military capabilities.
Aircraft are aging, so they have obsolescence issues, obsolete equipment. They also have a need for unique military capabilities beyond getting from point A to point B, some unique military capabilities that those end users need.
This is Les Worley, Business Development Manager at Collins Aerospace. A partner like Collins can help operators determine how exactly to pursue the work, ranging from relatively simple upgrades to a much larger scale effort.
We have equipment out there that's over 30 years old that we're still repairing, that it too will reach a point that we cannot get the components to repair that individual box, and it will have to be replaced or the system replaced. So we might be able to take that one line replacement item, LRU box per se, and pull out the old processing card and put in a new processing card. Pull out the old video card or video chip and put in a new one, and the box itself basically remains the same. We can do that on a case-by-case basis, but again, eventually we will reach the point that those components are no longer made, and it is much more efficient just to replace the entire avionics box and or system. Within an avionics system, there are so many pieces of equipment, from the displays that the pilots are looking at, to the communications equipment, to the autopilot on the aircraft. So sometimes you find that, okay, I can upgrade this one box, I can fix this one box, but now it doesn't integrate. It doesn't talk with all of the other older boxes that are on the aircraft that are working fairly well. But I really have to replace an individual piece, an individual component, and now I have an integration issue of the other equipment on the aircraft that might be a forcing point to replace more than one box.
Today, aviation crews must deal with more data than ever before, something that will only increase in the future. Processing this information and making it accessible for pilots and other personnel is a crucial focus for upgrades.
We're trying to get to the point where the pilots are not constantly talking on the radio to get the information, and then they have to picture it in their head where that other aircraft is. We want to put that information on their display, whether that's a multifunctional display next to their primary flight display. It might be in the center console. So tactical information coming up to the aircraft is very important in a training or a combat situation, where they can actually see a map of the area, and they can see their position, and they can see friendly aircraft around them. They can see non-friendly aircraft. They can see threats on the ground. All of that information needs to be displayed to the pilots, so they, at a snapshot, they can look at it and get their situational awareness. So we want to get more information. In order to do that, we need displays at the cockpit, and the larger the display, the more information we can put on it.
Collins has addressed this need directly through a range of systems, perhaps most notably its Flight 2 integrated avionics system. Les Worley explains how this technology can help address obsolescence issues and help maintain fleet availability.
So we designed and developed back in 1999 an avionics system, an avionics suite of equipment that we call Flight 2. It's still flying today. And we called it Flight 2 for the second century of flight. And this new system transformed the cockpits of the 60s and 70s into the cockpits that we see today. So we've talked about older equipment, all of these standalone analog gauges, individual gauges, one for fuel, one for oil, one for your situational awareness, your HSI, your ADI. And none of those instruments talk to one another. That's why we had so many of them. So the pilots are constantly scanning the cockpit, looking and reading those instruments. So when we developed this Flight 2 system, we removed those analog gauges. Just in the C-130, for example, just the engine gauges are 32 gauges that the pilots have to scan and monitor, and now can be removed. We did that with Flight 2. It's a digital system. It's an integrated system. The boxes are no longer individual boxes. They talk to one another. They are sending that information up to those displays that we talked about, whether it's a primary flight display or a multifunctional display. So that information is now being transmitted to the pilots, maybe additional crew members, and we basically transform the way that avionics had been developed over the years with this new system called Flight 2.
Military aircraft have a range of unique operational demands which must be supported throughout their lifespans. Here's Les Worley again, using the C-130 as an example.
C-130s carry cargo from point A to B, and they also drop cargo and paratroopers out in flight, both at high altitude and low altitude airdrops. We have designed into our flight management system an airdrop function that calculates the drop point for the aircrew. So whether they're dropping cargo or paratroopers, it assists them in a precise drop point so they can hit their target point and get that cargo or paratroopers where they need to be safely. Other things that military aircraft do and need to do that commercial aircraft do not, and that is operate in austere locations. So we don't always have the luxury, especially in a contingency or a combat operational area, to land at a nice airport and runway, concrete with lighting. Sometimes we need to land in austere locations, and that might be a dirt road. It might be a piece of flat land in a desert. And so our air crews need to do what we call a tactical approach. And our flight management system allows them to calculate that. It allows them to put in navigation points that will determine where that aircraft should start down in its descent, because there's no aids on the ground to tell them. It will tell them where their touchdown point should be and where their rollout point should be in this airfield that doesn't exist. So those types of capabilities, additional capability, those come along with our system.
Crucially, such upgrades can increase the mean time between failures. Essentially, this means pushing down the failure rate, a key demand if militaries are to boost fleet readiness.
So how often does that piece of equipment or system, maybe it's 2 or 3 pieces of equipment, how often do they fail? What's the mean time between the failure rates? And the older equipment, fails at a much higher rate than the new digital equipment. The new digital equipment, like your computer and your laptop. And so by replacing the vast majority of that older analog equipment with all new digital equipment, we greatly improve the mean time between failure. We also, when we do a major avionics upgrade, not only do we remove all of those old analog gauges, we remove the old copper wiring that's in the aircraft. It's all stripped out. But a good comparison here would be for people listening, whether it's their parents or their grandparents, if they can remember those old CRT, cathode ray televisions that we had. Not near as big what we have today, right? The 60, 70, 80-inch TVs. But these, if you had a 36-inch TV, a 40-inch TV CRT, that was a big TV, and it took 2 big men to move it. Very heavy equipment. Same thing kind of applies to the older analog avionics equipment on aircraft. much heavier than your digital equipment that we have today. When you remove that old equipment, replace it with lighter weight digital equipment, you remove the old copper wiring and you replace that with newer lightweight copper and aluminum wiring. You put that back on the aircraft. When an aircraft goes in for a major modification, it's weighed, and when it comes out, it's weighed to make sure they understand where the CG is on the aircraft. And we did that on an aircraft and determined that the weight reduction was about 1,000 pounds, just in equipment weight and wiring weight. That equates to fuel savings on every flight and significant fuel savings over the life of that aircraft.
The relationship between supplier and operator is a key focus. Collins Aerospace aims to build a strong internal service and repair capability for its components, becoming a trusted partner for its customers.
Some of the aircraft that we are upgrading today are over 50 years old. And I'll give you two examples, the KC-135 and the B-52. Aircraft over 50 years old, and the services have said they're probably going to fly some of those for another 50 years. So with systems like our Flight 2 products and systems, we want to make sure that we're hand in hand with those customers to help them sustain those aircraft so that they can fly another 50 years. We have a number of people in our military avionics business unit at Collins that are former military operators, whether that's they were a transport pilot, they were a tanker mechanic, whether they worked in the headquarters. So we have the huge advantage that we have that relationship built in with a number of the people that we have hired over the years, that they continue those relationships with colleagues that are still in the services or in other companies. You know, we have to have that trust not only with our end customers, but also with those other equipment manufacturers that we're working with.